Hey guys, this looks like a fun one. We're given a square with a quarter circle with an area of pi and a semicircle with an area of pi. And it wants to know what is the area of this square. And if you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. First, let's start by drawing the radius of the green quarter circle from here to here. And let's draw the radius of the blue semicircle from here to here. Let's call this radius little r1 and this radius little r2. And now we can set up some formulas with our new radii. For the first one, it's a quarter circle, so it's going to be pi radius squared divided by 4, where the radius is r sub 1. And that's going to be equal to pi because we were given that this area is pi. And then since this one is a semicircle, it would be pi radius squared divided by 2 equals the area of pi. And the radius in this case is little r sub 2. Now we can clean these up. Let's multiply both sides of this top one by the reciprocal of pi over 4, which is 4 over pi. And then on this one, let's multiply both sides by the reciprocal of pi over 2, which is 2 over pi. And now the reason we use the reciprocal is because these two 4s will cancel each other out, and these two pi's will cancel each other out. So on the left-hand side, we just have r sub 1 squared. And then on the right-hand side, this pi and this pi will cancel each other out, so we just have 4. And same thing down here, this 2 and this 2 will cancel each other out, and the pi will cancel each other out, leaving us with r sub 2 squared. And then on the right-hand side, pi and pi will cancel each other out, and that'll leave us with 2. And right now, both our variables are being squared, so to solve them, let's square root both sides of both equations. For this one, the square root and the square will cancel each other out, and the square root of 4 is 2. So we have r sub 1 is equal to 2. And then down here, the square root and the square will cancel each other out, and we're left with r sub 2 equals square root of 2. Now we can update the diagram. R sub 1 is equal to 2, and r sub 2 is equal to square root of 2. Next, let's draw this other radius of the blue semicircle, and it also has a length of square root of 2. Now let's focus on the square down here and look at its diagonal. For every single square, the length of the diagonal is square root of 2 times the side length. So for this diagonal, it's going to be square root of 2 times square root of 2. And square root of 2 times square root of 2 is 2, which is kind of cool because that's the same thing as this one. So now we know this whole diagonal. Let's look at the larger square, and we don't need these anymore. So the length of the diagonal of the larger square is 2 plus 2, which is 4. And now we can recycle these notes. To get from the side to the diagonal, you multiply by the square root of 2. But then to get from the diagonal to the side, you divide by the square root of 2. So if this diagonal is 4, the side would be 4 divided by square root of 2. And then since it's a square, this base would also be 4 divided by square root of 2. And now we're pretty much done. We don't need these notes anymore. And the area of this square will be base times height, which would be 4 over root 2 times 4 over root 2. And that's going to give us a fraction. On top, 4 times 4 is 16. And on bottom, root 2 times root 2 is 2. 16 divided by 2 is equal to 8. And that is the answer to our question. Let's give it a label of unit squared and put a box around it. How exciting.